easy to live? Does your life can you survive under the sun? I can't put my finger on it. Is it green? Is it red? Is it alive or is it dead? I can't put my finger on it. Scared with the live of the days in the past. I can't put my finger on it. Is it brown? Is it white? Is it really out of sight? I can't put my finger on it. Call it squeal, does it squirm? If it's fresh, will it burn? I can't put my finger on it. Can it fly? Will it try? If the wings are still wet, I can't put my finger on it. Can it heal? Is it real? Can it feel the threads of time? I can't put my finger on it. Does it glow? Will it shine? Does it leave a trail of slime? I can't put my finger on it. I said, are you surprised when I touch the blood inside? I said, are you surprised when I touch the blood inside? Are you surprised when I touch the blood inside? Are you surprised when I touch the blood inside? Is it alive? Does it life can you survive under the sun? I can't put my finger on it. Is it green? Is it red? Is it alive or is it dead? I can't put my finger on it. Scared with the live of the days in the past. I can't put my finger on it. Is it brown? Is it white? Is it really out of sight? I can't put my finger on it.
All right, so last week we left off SQL talking about data projections. And data projections are where you can take multiple pieces of data with certain dimensions, say 3 dimensions here with title, author, and num copies of books. And then you can project it down onto lower dimensions by using a group by clause. In this case, we're grouping by the author, so all the authors are together. Norman Mailer, Douglas Adams are all together. And then you project it down and aggregate that into a new piece of data. The total number of Norman Mailer book copies that we have in our collection is 13, 10 plus 3. Douglas Adams would be 4 plus 2 plus 1, right? We're taking a sum here. When we did that in our video game database here, we did it with respect to the number of games that each publisher has published. So we selected a publisher ID, and then the count of all of those records, and then we aliased it so that we would get a sensible name for this column, a number of games, from game group by publisher ID. And when I execute that, I get a report of publisher 1 has published 3 games, publisher 10 has published 2 games, et cetera, et cetera. Now, the problem there is that who are the publishers? When I did this, I'm just getting the publisher ID. That doesn't tell me that that's Nintendo or Eidos or Rockstar, right? It doesn't tell me who they are. And then the other problem is, what about publishers with no games? And there are plenty of those, right? So what I want to do is I want to get, well, here, not a count, but let's go ahead and I want the actual names of these publishers. And then I also want to include any publisher that doesn't have any games, because we have, 18 publishers, and then there are 21 games, but some of those publishers have duplicate games, that they've published more than one game. So we're clearly not getting the publishers here that have 0 games, otherwise they would show up in this column here. Now to do that, I'm going to have to start combining tables. For that, let's go back to our math. Right? So remember basic set theory here, especially if you've done it now in 235, where you've got two sets, A and B. Now I'm looking at this, this line right here, A and B. And A has three elements. Its cardinality is 3, A, B, and C, and then B has two elements, 1 and 2. If you were to take a Cartesian product of that, then what you're doing is you're taking pairs. A is going to match up with 1, A is going to match up with 2, B is going to match up with 1 and 2, C is going to match up with 1 and 2. Right? So in other words, you're taking a cross product, or in MySQL, you're taking a cross product of this, or a cross join is what we call these things. So you can take two tables and join them together, right? Let's just go ahead and start that blindly, right? You know what? For reference, let me go ahead and pull up our database schema here. Let's see, databases. Where's the video game database? Games. There it is. All right. So I'm going to go ahead and combine the publisher table and the game table. Okay. Now, before we do that, just keep in mind, how many publishers do we have? 18. How many games do we have? 21. Okay. So let me go ahead and join those two together. Select everything from game, join publisher. All right, there we go. And it's successful, but I get a lot of weird data. GTA 4 was published by LucasArts. I can tell you that that's not true, because GTA 4 was also published by Sony and by Square Enix and by Sega, right? I'm getting complete nonsense data out of this. Let's understand why we're getting complete nonsense data out of this. How many records did actually came back? 378. Now I told you to keep in mind 18 and 21. Right? What are the relationships between all those numbers? Select 18. Remember, I told you that you could turn this into a calculator. Times 21. And you don't have to have a from here at all, I don't think. 378. Where did we get that number? Well, that's 18 times 21, but where else did we see it? The number of records when you do a blind join together, right? A Cartesian product or a cross join. Just like ABC here has cardinality 3, 1, 2 has cardinality 2. So what is the total cross join? It's 2 times 3. In other words, 6 pairs here. Right? And that's what we're getting here. And of course, you get an infinite number if you consider the real numbers with the real numbers, right? So that's not what I want, right? Because it's giving me nonsense data. It's giving me every publisher matched with every game, right? Every publisher, LucasArts here, is going to be matched with every single game. If I sort by them, you'll see ABC here, which was a placeholder that we did, is going to be a publisher for every single game in this database, all 21 games. Right? So what we want to do is we want to cause a relationship, or a relation here. Right? Oops, not all the way down, all the way up. All right, there we go. All right, so some more math. All right. A binary relation between two sets, A and B, is a subset. Right? So, for example, R is going to be our relationship here, or our relation, and subset set equal A cross or times B. Right? So instead of taking the entire set A cross B, you're going to take a subset of that. For example, you can do the following. For example, you can say let R be a relation on the sets, or the sets math BB Z and math BB Z. All right. So what is Z there? 235, folks. Integers, right? So positive integers, negative integers, and 0 there. So if I look at like all pairs, right, that are defined by A is less than or equal to B, let's say, for A, comma B in this relationship, okay? So in other words, A and B are related only if they satisfy A is less than or equal to B. So for example, is, I don't know, let's go with 5 and 10, right? Is that in the set or not? Question mark. Is 5 less than or equal to 10? Yes. Here's another example. What about 5 and 5? Right? Is that in the relation? Is 5 less than or equal to 5? Yes. Finally, what about 10 and 5? 10 and 5. Is that in the relationship? Nope. So we would negate that and say that it's not in the relationship. Okay? Clearly, it's going to be a subset of all of those integers. In fact, if you want to visualize it, what would it look like? You would draw an identity line across the Cartesian plane, and everything above that is in the set. Everything below that is out of the set, out of the relationship. Right? So, what's our relationship over here? By the way, this is called a relation. Why do we call them relational database management systems? Because this is their mathematical basis, right? Okay? They're all based on relations. Now, what is our relationship between a game and a publisher here? Again, let's go back to our ER diagram here. How are records in the game table related to records in the publisher table? That's the purpose of a foreign key. If this publisher ID matches this publisher ID over here, then that means that this game was published by that publisher up there, right? That's the parent-child relationship. So what I'm going to do is I'm going to put that on a condition here. I'm going to select everything from game, join publisher, right? Actually, let me rewrite this so that this is the blind cross join, right? In other words, it's A cross B, not what you want. So let's go ahead and copy that and improve that, right? In other words, what you want to only relate related records, right? You only want related records. That's a better way of putting it. You only want related records, and so to do this, you add an on clause, right? So join everything from game, join publisher, on game.publisher ID is equal to publisher.publisher ID. Right? You've all seen this dot operator before, right? It's the direct component selection operator in C. It is the class dot and then whatever the method or state or whatever you want, right? It's in every language, right? If you've got an entity within an entity, or in this case a column within a table, then you use the dot operator on it. So those two things have to match. And note here, I am not using equals equals because that's not correct syntax. We only use equals here. So only select games and publishers such that their publisher IDs match. All right? Execute that now, and I only get about 21 records, exactly 21 records here, right? 20 and then 23 here. Assassin's Creed, published by Ubisoft, up here. Rockstar Games now has these four games and these 4 games only. It starts to make sense. GTA series was by Rockstar Games, not by Nintendo, not by everybody. Okay, I am only getting the things that match now because their publisher IDs 6 and 6 or 5 and 5 they now match. Okay, you can shorthand this. You can shorthand joins using aliases for tables. For example, I'd had to write game and then I had to rewrite publisher here. What I could do then instead is use an as clause here, G, and publisher P as P, and then say that on, let's just write it, on G.publisher ID is equal to P.publisher ID. Right? And that's a little bit more succinct way of putting it. In fact, you can even make it shorter. Since you're doing this all of the time, you do not need to put in the as keyword over and over and over again, right? And there is as short as I can get it, right? And that's the exact same results as before. All 21 games there with their publishers, okay? So now let's come back up here and try to solve these two problems now. Who are the publishers, right? What I'm going to do is I'm going to now repeat this, but instead of just doing it on the game table, right? What I'm going to do is I'm going to, let's go ahead and go to the next line and then group by at the end. From game, G, join publisher P on G dot publisher ID is equal to P dot publisher ID, right? And then group by the publisher ID. Careful. It won't work here. And it's saying that the publisher ID field is ambiguous, right? Because there are actually two publisher IDs, remember? I have a publisher ID from the game table and a publisher ID from the publisher table. So now I have to be a little bit more descriptive here. Which one do you want to group by? Well, they're all the same, so you might as well go with that, but always associated with a primary key here, p.publisherID. Again, it'll have the same results if you go with the game ID, but that's the foreign key in the game table. This is the primary key, right? So generally prefer primary keys instead. Oops, sorry. Then right here as well, p.publisherID. There, I did it in two places. All right. So now I can fix this. Instead of being a publisher ID, I can say publisher name as publisher name. Right? There. Now I've got the publisher name along with the number of games that they've published. LucasArts has published 3 games. Namco has published 1, etc. Right? Note that neither one of these columns, publisher name or number of games, is anywhere in my table here. One is an alias, and one is now an aggregate based on a join to another table. Okay? Now there's still a problem here, right? What about publishers with no games? And that's going to require a different type of join here. To understand that, let's go over here to, where do I want my joins? Right there. Yeah, there we go. So here's the inner, what we just did was called an inner join, right? And it's basically like this, right? Where say I've got 2 tables. I've got an email table on the right and then a student table on the left. And I'm going to join them together, but only if their student IDs match. So 1234 Starlin Castro here is going to match with 1234 Starlin Castro there to give me his number 13 at cubs.com. Right? 5678 is going to be matched with 5678 over here to give me Rizzo. And then 9988 is going to be matched twice, right, with Ryan Sandberg here because I have 2 of these. Okay. What about Dale Sweem right here? Right? 1122. Do you see a student ID in this column right here matching that record? No. Consequently, he is not included in this inner join. Now the opposite, now to solve this problem, what we're going to do is what's called an outer join, right? A left outer join specifically. So that what we're going to do is we're going to include everything, even if it doesn't have a matching record over here. All the blanks get filled in with null values, okay? So let me come back over here and show you that there's a different type of join, right? So this is let me come back up here and say that this is a blind cross join. You only want related records, and this is an inner join. Right? Now let's do an outer join, outer left join. Right? You use this when you want to preserve records from the left. Right? Okay. So let me try that. Okay. Select everything from game, left join publisher P on that same condition there. I'm still going to get the exact same results as before, right? Because this is what's called a left join, right? It's going to preserve records from the left. But which way did I go? I started at the game table, and then I went over to the publisher table. That's the backwards way, right? Generally, you want to read left to right, and that's why I organized my ER diagram like this. Let's start instead at the publisher table and then join to the game table. Okay, so let's switch these around. I'm going to put a publisher up here, and then I'm going to move game down here. There. Now, if I just did a regular old join, it's going to be the same as before, right? I'm not going to get any of those publishers with no games, right? But if I now change it into a left join, preserving records from the left, from the publisher to the game table, now I get a whole bunch of different results here. For example, Sony Entertainment, Square Enix, and Sega, null values over here. They didn't publish any games according to this database, right? But their records on the publisher table have been preserved here. Again, this is technically a left outer join, right? Same result as before, but it is so common that you just omit outer, and also you omit inner. Okay. All right. So now that I've got that, I can modify this even further. I can modify this one even further. All right. And let's bring this down here. And remember that I have to start at the publisher table first. Right? So let's switch these around. Right? And then if you want to, you can go to the next line on the on here. So I'm going to select the publisher's name and the number of games from publisher P joined to the game table on their publisher IDs, grouping them by their publisher ID. That's going to be the exact same thing as before, but if I change this into a left join, now I'm getting a lot more results. Do you see the difference in results? Right? LucasArts is still 3. Right? If I look at Rockstar Games, there's GTA 1, 2, 3, and 4. So 4 right there. But what about Sony Entertainment, Square Enix, and Sega, the ones that I just mentioned? 1, 1, and 1. Is that true? Did they publish one game? No, we know that that's not true if we look at this. Right? Sony, Square Enix, and Sega, they didn't publish anything. So what's happening here? I'm counting what? I'm counting the number of rows. Well, how many rows do you see for Sony Entertainment there? I see 1, right? It's just that it doesn't have any data in half of it. Right? So I shouldn't be counting rows. What should I be counting? Game IDs. Right? That uniquely identifies a game. Because I want the number of games, I should be counting something that uniquely identifies the game. So g.gameID. Right? Nulls will be treated as 0. So if you're summing these up, if you're summing up the number of rows, so you're counting the number of rows, you're only counting things that are not null. Now, Sony Entertainment, Square Enix, and Sega, they now have 0. 0 and 0. I have now solved this problem. Okay? I was able to produce a report that gave me the publishers along with the number of games that they published, giving me a human-readable readout of this data, Sony, along with preserving records that don't have any the games at all, giving me the correct value, 0 here. Okay? All right. Again, it is a left join. You might be asking yourself, is there a right join? And the answer is yes. Right? Let me show you. Let me come back up here and start at the game table and then go over to the publisher table. There we go. And I will change this immediately to g.gameID, right? And this one to a game to the publisher. That looks good. That all looks good. Now, visually here, what am I doing? Is I'm starting at the game table and I'm going to the left. So if you want to preserve records from the right, you would use a right join. Right? And I get the exact same thing as before. Right? This is exactly the same report. LucasArts 3, and then these 3 guys don't have any. Right? And then the rest of them I assume are the same. Right? But I am preserving records from the right. By going from the game table to the publisher table, I'm reading right to left. How many folks read right to left on a daily basis, though? Right? In English, I should say. Right? Not me. So yes, but it forces you to read in reverse. Right? So sometimes you need it, though. ... How? Let's go ahead and do one exercise here where I flatten the entire data model. In other words, we started out with a bunch of CSV files, right? We started out with files that looked something like this, right? And then we pointed out that there were a whole bunch of problems with this in the notes, right? That there's repetition of data, there's bad data representations, et cetera, et cetera. Then we introduced the relational database model here and saw how it solved most of those problems. Now what I want to do is I want to come full circle. I want to take this relational model and I want to flatten it out completely. Right? Let's go ahead and start at the publisher table, then go over to the game table, then go over to the availability table, then the platform table. In other words, I'm going to join 4 tables together. Joins don't just work with 2 tables, it works with as many tables as you want. Start at the publisher, game, availability to platform. Right? So let's flatten the entire data model. ... Right? So select everything for now from publisher P, join. Right? In fact, what should I do immediately if I want to preserve records? Left join, right? Left join game G on p.publisher ID is equal to g.publisher ID, right? And then, I don't know how you want to do this. Let's go ahead and go left join, left join, left join. There we go. I like that a little bit better. Left join, availability. Would it make sense to immediately jump over here to platform? Are game and platform directly related? Nope. We're using this join table in between. By the way, that's why you call them join tables, because they join two tables together, right? Availability A on game dot or g dot game ID is equal to a dot game ID. Did I just memorize the entire data model? I'm not really looking too closely at what the names of the tables are, what their in fact, I'm not even looking at it right now. What their primary keys are, what their foreign keys are. Right? Why did I not even have to look at this to remember that? Look at all the primary keys. What are they named? Table plus ID at the end. What about all the foreign keys? They match the primary keys that they refer to, right? What about all the tables? They're all lowercase, they're all singular, right? So I followed a sensible and consistent naming convention. I don't have to keep going back and forth. What did I call them again, right? Just like you follow a consistent naming convention in your classes, right? In Java. So join, what is it, platform, P on, availability, so a dot platform ID is equal to p dot platform ID. Now there is a problem here. Do you see it immediately? Pay attention to the aliases I used. P, G, A, and P. So that's what it's going to complain about. That I reused the same variable name here, the same alias name. I can't do that. I have to get this plat or something like that. Plat, right? P1, P2, don't do that. Shorten it up, right? There we go. Now I've got LucasArts here, and they're in there 1, 2, 3, 4, 5, 6 times. Remember, they only published 3 games, but they published Lego Star Wars here 4 times on 4 different platforms. Mac, PC, PlayStation 2, and Xbox. Right? There's Sony Entertainment with all the way through, left join, left join, left join. All of their records don't have anything because they have not published any games at all. There are some games that have been published, like Rockstar Games GTA 3, that are not available on any systems. Right? Okay. Well, all right. That kind of flattened the data model, but we really never took a close look at that platform table. Right? Let's select everything from platform, sorry. Right? Xbox, Xbox 360, et cetera, and then what we did on another class period was I inserted 3, more recent platforms: Switch 2, the Valve Index, and Playdate. And if you've ever seen a Playdate, it's this little nice handheld gaming system with a crank, right? So look it up if you want to. It's kind of just a novelty thing, right? Unfortunately, I don't think that they ever got to season 2 of their game releases. Right? All right, so were those represented before? Let's find out. Right? So let's go ahead and sort these by their platform name. Do you see Valve Index here? Index at all? I see Playdate, but that's because apparently Assassin's Creed, published by Ubisoft, was made available on Playdate. It's black and white screen, and it's only this big, so no, that's not true. Right? But I don't see the Valve Index here at all. Right? Why is that? We started at the publisher, went over to the game table, went over the availability table, went over to the platform table. So we only preserved left to right, 1, 2, 3, 4. What about the records over here that don't have any games on them? We're missing those. So let me go ahead and go in reverse order here. And instead of retyping everything, what I'm going to do is I'm going to change all of these to right joins, and right joins. Now it'll preserve platform records, right joining back over here to the availability. It'll preserve records there, joining over to the game, records over here, joining to the publisher. And we see down here, Switch 2 does not have anything published on it yet. Where's the index? Just below it? Okay, apparently Assassin's Creed is available on that as well. Right? Anyway, so Switch 2 here is now preserved. Okay? But, hey, let's run that again. What about all those records that were being preserved from the right, or from the left, excuse me, right? LucasArts here, remember that they should have a lot more, right? Who was it? Sony Entertainment. They're not represented here at all. Why? Because I'm only preserving one direction, right? You can either go left or you can go right, but you can't go both ways. Right? So now back to our math, right? So consider two sets. Consider two sets, right? A and B, right? What we want are record, right? This was set A. This was result A here, preserving from the left. This was set B here, preserving from the right. I want both of those. I want both of those together. So what are two basic set operations that you can do in math? What about this? What is that thing? That's the union, right? What about this thing? A, and then just the opposite, cap B. That's what? Intersection, right? Well, if this is all based on relations, and relations are nothing more than sets, do you think we might be able to combine these two using a union? Yep. Got to get rid of that semicolon then. Because what it's going to do is it's going to execute this command right here, this set. Then it's going to execute this set right here. And then it's going to take the union of those two things together. And there's the big, giant, flat data model now, right? Sony Entertainment is being preserved from the left, and Switch 2 is being preserved from the right, right? And now you can dump this to a CSV file, right? There we go. You can dump this to a CSV file, or you can dump this to an HTML table, or to JSON. Hey, that looks familiar. XML. Or you can dump it to a series of SQL insert statements, right? Or whatever you want, tab separated value file, right? So it's all coming full circle now, right? Data and data representation. You start out with a flat file, CSV. It has JSON, XML equivalents. And now we're all the way to a more sensible relational database management system model. Okay? All right. Let's see. I don't necessarily want to start the next thing, so let's go ahead and do some more reports here. Right? So write a query to determine how many games were published on each platform. Okay. So you're going to help me write this query. Okay. So for each platform, what I want is, index. And it's like 5 games or something. I want NES, and it has 10 games or something. I want something that looks like that. Okay? So let's look at the data model. Where should I start? First of all, is the publisher relevant anymore? No, the platform is relevant. The game is relevant in some sense, right? So I want to start at the platform. Let's go ahead and select everything from platform. All right? And I'm going to get all of these platforms here. There's the names. That's what I want. Okay. But now I want to join over here to the availability table, at least so that I can get to the game table. Right? So let's go ahead and do that. Right? So left join. Why left join? Because I want to preserve records. If there's a platform with Switch 2 with 0 games on it, I want to know that, right? So left join availability A, and then let's go ahead and get P here. There we go. On P dot platform ID is equal to A dot platform ID. Okay. Now I've got Xbox, ... Now I'm over here to the availability table. There's Playdate, there's Index, there's Switch 2 with no records. Those are being preserved. Now, do I have to go all the way over to the game table to start counting the rows that I just have? Nope. I can stop short, right? If there's a row that has been preserved with a null game ID, then I can count that as 0. Right? Why do you need the name or the publisher if you already have the game ID over here? Right? So I don't need to go that far. I could, but why? Right? So I will group by. What do I want to group by here in this instance? Game ID, right? So I definitely want to count the game IDs, right? And that's going to come up here to play. But what are you grouping them by? Remember, let's go over here to, now it's all way down bottom. No. Where is it? There it is. All right. I want the preserved records. Where's the other table? Inserting data. Oh, there we go. There it is. All right. So what we wanted to do here was we wanted to group them by their authors so that we get the number of copies here. So if I want a report that tells me how many games there are, right, per platform, then I want to group by their platform ID. Now be careful here because we have two platform IDs. So which one do you mean? Go with the primary key, not the foreign key. Okay? That'll give me something that looks like this, right? But it looks like this because there's no aggregate up here, right? So what I want is everything and then not a sum but a count, right? Of everything? Nope. Where's that play date? Play date should be 0, right? So what should you be counting here? Well, with play date, switch 2 should be 0, right? And I should count nulls as 0. Therefore, I should be counting the game ID, right? So, and where's the game ID? It's in the availability table, game ID. There we go. There. Xbox has 1. Switch 2 has 0. Game Boy has 2, etc., etc. Right? Now let's go ahead and winnow that down because we don't care about all of those columns, right? Some of them don't even make sense. Xbox has 1 game published in 2005. Maybe that's true. But Xbox 360 has 3 games all published in the same year. That doesn't make any sense. Okay? So I only want this, the name of the platform. Where is that? The name of the platform right there, along with this field right here. So p.name as platform name, something like that. And then the count as number of games. There. Now, again, you don't want to use the star operator here. If you did, then you're sending over a whole bunch of data over the wire, and then you end up ignoring it on the other end. To this day, in 2025, we are still bottlenecked by network lag, right? You can have the fastest memory, you can have the fastest processor, but I could still load up a semi-truck full of hard drives, drive it across the country, and still get there before you can send the equivalent amount of data, right? Over the fastest network available, right? Why? Because that's still the bottleneck, right? So sending stuff over the network, if you're not going to use it, makes absolutely no sense. Don't do it, right? So generally, you should not use the star operator when we get to programming. Of course, you can use it here as we're debugging because we're just developing this stuff, okay? All right. Is there another thing that you'd want to see? I mean, what else could we do here? Remember, we wanted the publish year of the oldest game, right? So what was that actual game? What was the publish year of the newest game, right? So find more info or complete info about the oldest game, ... right? So select the min of the publish year from availability, right? 1985, that's the example that we gave last week, right? But now what I want to do is I want to actually find that game, right? I want to find the game whose publish year is equal to 1985, right? So that's going to involve joining these two tables together, right? All right, so select everything from game G, left join. Do I need to do a left join here, right? So if there's a game that's not been made available on any system, what value is the publisher going to end up having? Null, right? That's not a valid year. Do I need to worry about preserving game records over here that have no availability if I already have 1985 sitting in my hand? Right? Nope. So let's just go ahead and do a regular old join. Right? Join availability A on G.GameID. is equal to a.game ID. There we go. All right, now where's that 1985? Right there. Super Mario Brothers, 1985. All right. But that didn't give me that one game, right? I could put in a where clause, where a.publish here is equal to 1985. And now I'm getting that one game published in 1985. Okay? That's still not all that satisfactory because I had to run a query once, see that, oh, it's 1985, and then hard code this value right here. Right? So what I'm going to do is I'm going to replace this with a subquery. Right? So select everything from game, join availability, where a publisher ID is equal to, and then make this other query that gives me 1985 out of that. Right? And now I'm not hard coding anything. Right? Hard coding values is okay for test data or mock data, but not for actual queries. All right. I can go ahead and change this to max and get what the newest game is. Right. There we go. Oh, it looks like it's Assassin's Creed 2025. That's because that was fake data that I put into for Playdate and Valve Index. All right. By the way, the reason that I did that was because I wanted to show the other class how to do something like this. Insert into game, name and publisher ID, values, Assassin's Creed 2. There we go. And then whatever the publisher is, let's just say 10 for now, right? Okay. What's going to happen there? Why is it not compiling, or why is it giving me a syntax error? Because of that single quote there. How do you think we solve that? Okay, option 1, use double quotes instead. There you go. Option 2. Yeah, you escape it. How do you escape? Like, what if I wanted to put in an endline character? Like that, right? So how do I escape this single quote? Like that. Assassin's Creed 2. Right? I have no idea who the publisher is. Ubisoft or something, I think, right? Anyway, I'm not going to run those commands. All right, any questions? No? All right, then I didn't want to get to it, but I did prepare for it. What we want to do next is start designing our own databases. Right? So this one was given to us because that we wanted to do Crud first, create, retrieve, update, and destroy. But how is this actually designed, and how did we actually write code to create these databases? So when we come back on Wednesday, we're going to create a database to model that asset Java program that we did, with it where we have an asset, an annuity, and a stock, as well as a person who is an owner, and that person had the emails, and et cetera, et cetera. In other words, this thing right here. I dumped it to a UML image right here. Right? Again, this is what we're eventually going to see in your design documents. Plant UML, I put that into the object-oriented programming notes. This is what I use Plant UML to generate this thing. It's easy to use, that's why. Right? There are other better solutions, but they either cost money or they're way more complex to use. This one, you just select classes. So we're going to want a way to model a person, which is not in this diagram here. We're going to want a way to model an annuity, a stock, an account maybe, and when we do that person, we also want multiple emails. So we're going to have to start creating tables. And generally, the rule of thumb here is going to be, if there's a class, you probably have a corresponding table. It's not going to be a strict guide. That's just a guideline. That's a rule of thumb, not an actual rule. Because ultimately what we're going to do is we're going to take these three classes and we're going to crunch them down into just one table for simplicity. Okay? But we'll do that on Wednesday. No questions? All right, remember assignment 2 is due this Friday, along with assignment 3's bonus, 1 week early bonus if you're going to go for that.